Hello everyone, I'm Mark. Welcome to our channel. Today I'm going to cover some things in reference to measuring tools and different angle blocks, things like that used during measuring, doing machine work. So some of the tools I use on a regular basis, some of them I don't use very often, and I've got a couple tools I purchased I haven't even used yet. So let's get started. Okay, the first thing I want to get started with are more simple things, the simple measuring tools. Of course, the most basic thing to measure with is a tape measure. We all know what that is and how that works. A lot of these tools, I've got a lot of tools to go over here today, so I'm going to go fairly quickly. In future videos, I will actually show them being used. And then you have what they call a Machinist scale. It's a steel rule. People call a lot of different things. They come in different sizes, different lengths, different graduations on them. But that's pretty much the most basic measuring tool you're going to use as a machinist. I have different styles like this one here. This is it's a small scale to getting down into tight places, and you can also take the scale out and put it at the end of this handle and reach into different places. I use those quite a bit. They're very handy. And then you get into things like calipers. They have vernier calipers, they have dial calipers, they have digital calipers. This is a dial caliper here. By obvious reasons, it's got a dial on the face. So you know every revolution on this thing is 100 thousandths. And if you look down here, it's measured out in 100 thousandths, and you get to an inch. Right there. That's exactly 1 inch between the jaws. It's also 1 inch between here. And if you're using it for a depth gauge, you can measure from here to here down onto an edge, and it's exactly 1 inch from there down to there. So if you're wanting to get down, measure on something, you can slide it down on there, and it works as a depth gauge also. Then on the other end, you have a fine tip that goes down into holes and stuff to measure a depth gauge from this face down to this face. And whatever this measures on the scale here, that's what the distance is from here to here. Very simple, very easy to use. And of course, again, they come in different lengths here. Here's a 12-inch dial caliper. Back years ago when I was a young guy working in a machine shop, I couldn't afford to buy, 24-inch dial calipers, so I bought these. This is a Vernier Scale caliper. And basically you read it same way you'd read a dial, except it's straight instead of on a dial. You have your main measurements here, and then, there's 1 inch, 2 inches, 3 inches. And this one is measured off, most of them are measured off in 25 thousandths. This one's measured off in 50 thousandths. It's just more, just the way they did this one. And it works the same way. You line up this here, and then you come down until the line matches here to a line here, and that would give you, like on that one, it would be 3 inches, 800, and looks like somewhere probably around 8 inches, 40 thousandths or so is what that measurement would be right here. And then also on the outside here, you can have measurements. So that's how those work. Very simple. They also make them in a depth gauge type of tool. Again, it works the same way. You have your Vernier scale. Now this one's in 25 thousandths across here. That's the way most of them are. And you read it exactly the same way. You go to your furthest point where the zero ends up, and then that point, and then you measure down and line up to where one of these lines lines up with the line on the scale, and that will give you your reading. It sounds a little complicated, but actually it's not. It's very easy to use once you get used to using them. They're very easy to use. For years, I used Vernier calipers instead of dial calipers. It was just, like I said, back when I started as a machinist, I couldn't afford all the fancy tools, so I had to use what I could afford and adapt from there. Okay, moving on into thread measuring. Again, they make several different types of thread measuring tooling. This is probably the most common. You have the blade type. This one goes from 4 threads per inch, which is standard threads, all the way up to 84 threads per inch. And I don't know how good that's coming in on the screen, but you can see how coarse those are. You can visibly see them. And then you look at 84 threads, it just, even sure you can even tell they're even there. They're so fine. I've never had threaded anything that fine. I've done some pretty fine work, but never nothing that fine. And of course, they have different style thread gauges. This one has standard threads on one side, metric threads on the other side. And I don't want to go into a lot of depth on threading and everything, but you know, standard threads are measured threads per inch, where metric threads are thread millimeter per thread. So I'm going to do a future video on threading in a lathe, doing single point, and how to do thread repairing, how to chase threads that are damaged, need to be cleaned up using a single point method. I'm going to go through all that eventually. And these are just different styles of thread pitch gauges. This is for Acme thread. It's for 29-degree Acme pitch thread. And then if you look here, again, I don't know how well that's coming on the screen. If you can see the numbers on there, that corresponds to the number of threads per inch. And basically, you sharpen your tool to this angle, and then you grind the point flat to where it fits in this groove, and that's the right size for the thread you're cutting. And when you're setting up in a lathe, this is your half of your 29 degrees, so you can set up to line your tool up so it's pointed perfectly straight in with your part. These are for doing 60-degree V thread, which is probably the most common thread you'll see out there. There's a lot of different kinds of threads. Again, in the future when I'm threading, I'll talk about that. But the majority of them are 60-degree V thread, sharp V thread they call it, whether it's fine thread or coarse thread. And if you look at, I do have one gauge here. This is a British Whitworth thread, which they're cut at 55-degree angle. Again, I don't know if you can see that on there, but you can see the difference. This is a 60-degree pitch, and this is a 55-degree, and you can see the difference. So if you do have different pitch gauges, make sure you grab the right one when you're sharpening your tool or when you're setting it up in the lathe. You use this to sharpen your tool. You also use it to set it up in the lathe to make sure your tool's perfectly straight with your parts, so that you're getting a good even 30 degrees on each side of your thread and sharp V thread. Okay. Of course, you have the same thing with feeler gauges. They're just basically thickness gauges, and they make them in different styles. These are bent, but they all measure out, real thin down to, a thousandths all the way up to, usually they're like 25 thousandths thick for blades. This is just another style of them. You got this kind here where the blade is actually tapered a little bit, so you need to get down into areas. It works exactly the same as this, except, they're just tapered on each side. Again, most people understand and know how to use those. Another type of thread measuring, which I've used a lot in my career, is thread wires. The most common set was a PD thread measuring wires. And basically, you have a chart that tells you what size wire you need for what pitch thread, and you put two wires on the bottom of the thread and one on top, and then you measure across it with an outside mic, and they give you a chart here of what that dimension should measure when the thread's cut to the proper depth, and they work very well. I used them a lot, and they're very accurate. That works really well in a job shop atmosphere. That's what I'm familiar with. When you don't have the mating part that's going to fit those threads, you can use thread wires to make sure that it's the right size. Normally in a machine shop atmosphere, you take the nut that's going to go on the thread and you machine the threads, keep cutting them until the nut fits. But this is the way to do it if you don't have anything that fits the threads, or if it's got to be a perfect thread. This is called a planer gauge. It's called a planer gauge because it was used when you ran a planer, and the difference between a shaper, a metal shaper, and a metal planer is on a shaper, the table's stationary and the ram moves back and forth across the part. On a planer, the tool is stationary and the table moves underneath of the tool, and that's the difference between a planer and a shaper. Again, you could use this on a shaper. I've used it in a vertical mill. It's just called a planer gauge. That's, I think, what it was originally designed to use. And you can put different tips on it and stuff. It's for setting your tool depth, and also you can measure with it too. You can go underneath your tool, measure, and then mic across this and find out what your measurement is. But that's what that was used for. And again, I bought this off a guy. He had it. His dad actually gave it to him. He never used it, and it's probably been 40 years ago. I just thought it was a cool tool. I love tools, and I really haven't used it that much, maybe a couple times, but I just liked it, so I bought it from the guy. I love tools. When it comes to measuring for gear teeth, it's kind of similar to threads. You're measuring the pitch of the tooth, not the number of teeth around the gear, but you're measuring the pitch of the tooth. So on a gear like this is one of the quick change gears off my lathe. You look here on the chart. Again, I don't know how well this is showing up on the camera, but there's two different pressure angles that gears use. 14.5 and 20 are the most common, and 20 is more common today than it was years ago. Originally, 14.5 was kind of the standard for pressure angles on gear teeth, and over time they developed a 20-degree pressure angle and started using that. It's a lot smoother pressure angle and works a lot better. But the way you would figure out what pitch this tooth is, you would find one that fit it close and it rolls freely in there. And I know you can't see this on camera and you can't feel it, but when I roll it there, I can feel it's kind of clicking a little bit on the teeth. So that's 14.5 degrees. So if I go this way with a 20.5 degree, it's a lot smoother. So I know that gear is it's a 20 pitch, 20-degree pressure angle gear. And if you get one that's the next size smaller, which is 24 there, you can see it won't even fit in the teeth. Or of course, if you go the other way, this is a 16 pitch, it won't fit in the teeth. So it works kind of like a thread gauge. You just find the one that fits and check which side of the pressure angle works the best. On newer gears, newer things, you're going to find mostly 20-degree pressure angles. And again, I want to do a video in the future on gear cutting, gear repairing, how to repair a tooth with. I was fortunate in my background, the machine shop I worked at, we worked on a lot of different things and a lot of big equipment. Gears 4 foot in diameter, and we did a lot of bowl gears, and they would be maybe this diameter and a pretty coarse pitch, and we would finish them by hand and actually make a plaster mold, and again, I'll get into that in the future. It's just another type of cheap gear gauge. Into measuring holes. This is called a telescoping gauge set. Any good machinist knows you call it a snap gauge, because basically you squeeze it down, lock it down, put it in the hole and snap it out, lock it down, and then as you take it out of the hole, let me get one, this one will fit better. You put it in the hole, you snap it out, you can see it snap in the hole there, and then you slowly work it out, and then you measure across it, with the right size outside mic. That one's too small, of course, and then you would measure your dimension across there, and that would give you the size of that hole. It's amazingly accurate if you get the feel for it. Just like using a micrometer, you have to have the feel for it. I never like to borrow anybody else's mics because everybody sets their mic to their feel. I have a very light feel when I'm micing over the outside of something. Other people really tighten down on their mic, and not to say either way's right or wrong, it's just how you set your mic up for your feel. And if somebody uses my mic, they might mic incorrectly because they're used to tightening it down to get the measurement, and where I'm not. So you want to be aware of that if you borrow someone else's mics or if you're setting up your own mic. This is another type of hole gauge. Again, it's for smaller holes. This one goes from 0.400 all the way up, or down to from 0.500 half inch down to 0.200, a little under a quarter of an inch. So you basically just put it in the hole and you slowly tighten this down and rock it, and get the measurement across that point right there. And then again, you measure across in the mic and get a measurement that way, and read your scale that way. And that'll give you, again, if If you do it correctly, they're very accurate ways for measuring smaller holes. When you get into bigger holes, you have inside mics, and they make several different kinds. This is a tubular inside mic because it's made out of a tube. They have other ones that are, it's like a stick, just a stem mic. It's just I'm not sure what diameter it is, but it's a smaller diameter rod that comes out each end of the micrometer for measuring. And you can put different ends on this, screw them off, screw them on, to reach. I think this mic goes from 1.5" ID all the way up to 8" ID. And then again, reaching down into a hole, you got this handle you can clamp on here for reaching down into a hole. And then they also have mics. I have a set of mics here. Again, it's a tube mic, and it goes all the way up to 40 inches down to 4 inches. So that's another style of inside mic. Outside mics, they make several different kinds, different brands, different features on them. This mic is my very first mic, and it's a 0 to 1 inch mic. It's a Mitutoyo. I bought that when I was 12 years old. I bought it, a friend of mine bought it new. He was a freshman in high school, took a machine shop class. He bought it for his class. The next year, I went in a machine shop and I bought it from him. I think I gave him $12 for it, or $8, I can't remember now. But I've had this since I was 12 years old. I'm 63 now. I've used the heck out of this mic and it still works perfect. It's got carbide faces. It's got the thimble lock. It actually has a slip thimble here for friction when you're setting it. Some of them have a ratchet on the end of them, some don't have anything. But I don't normally use that. I slip my fingers on it when I'm tightening something down, and it's just the way I've always done it, and I get a really good feel for the mic. This particular mic has a Vernier scale on it, so you can not only measure here, but you can come around here and do the same you do on the Vernier calipers and things and get it down to the 10th. So not all mics have that. This particular mic here is a Stereo. I've had it forever also. It doesn't have carbide faces on it, doesn't have a lock. It does have the slip thimble there. You can see how it slips, friction thimble, but it doesn't have the Vernier scale. Again, it works just fine for 99.9% of the stuff you do. Most stuff you do in repairing and job shop, you know, most stuff plus or minus a half a thousandth is plenty good. We get into some stuff that is a lot more critical than that, but that pretty much takes care of 99% of the work you do in a job shop. This is a digital micrometer. I don't have the battery right now because I never use it and I don't want it to corrode in there, so I don't have a battery in it right now. But basically it works the same thing as way as the other mic, except it's got a digital readout on it instead of a scale. It still has a scale on it. You still use it as a regular mic, but that's a lot easier. You screw it like if you're doing production checking or something like that. But I got it years ago used, and I've just never used it. Okay, one other thing that most people have probably maybe never heard of or never seen before are pie tapes, and they make them in different lengths. As you can see here, this one goes from 24 to 36. This one goes from 72 to 84 inch. They're kind of limited on their measuring distance, but they're a really cheap way if you got to measure large diameters. See, this one goes from 84 to 96, so this thing will measure something that's 8 foot in diameter. The only bad thing with a pie tape is it'll tell you the circumference of a part, but it won't tell you if it's out around or not like a micrometer will. So basically the main thing these things are good for is if you're machining a shaft and you know it's round, you just don't know what size it is because you don't have a mic that big. It's a lot cheaper to buy a pie tape that'll go out to 8 foot than an 8 foot mic. I don't think I've ever seen an 8 foot mic or seen how much one would cost, but I can't imagine what it would cost. Plus just handling it, it'd weigh a ton. So the way the pie tapes work, I've got one out of the case right now. I'll show you real quick. It's a 12 by 24 to 24. Basically it looks like a piece of banding material. You can see right here. And it's the area that doesn't measure in because it only measures 12 to 24, so the scale's not going to go down smaller than 12 inch. So the scale starts here at 12 inches. And again, I don't know how well this is coming in on the camera. But it's a Vernier scale again. You have the strip on one side that goes from 12 inch to 24 inch, and then the other end, as you wrap it around a part, you would slide this along the scale like that and read it just like a vernier caliper. On this side here, it goes from 0 to 25, and this side here has the inch measurements. So you would just slide it down until it lined up, till you were tight on your shaft, and then you'd see where this line on this 25 scale lines up with the upper scale, and that would be your measurement. Again, they're very easy to use, they're really accurate. The only downside is, like I said, they won't measure out around this on a part, it just measures circumference. So that's the only downside I can see to them. They're very accurate, just as accurate as a micrometer. Okay, some other things I've got here. I'll miss this one real quick. Let me do this one first. V-belts. If you're at the machine, a V-belt groove. This gives you the size of V-belts. This is an A belt, B belt, and so forth all the way through. And it gives you the pitch diameters. If you're over, like on this one, it's a B belt. If you're over 7.35 pitch diameter, you use a 38 degree, God, these things are dirty. I can't even read them. 38 degree angle and cut this to this depth. If they're, let's see, that one says if it's 735 pitch diameter and smaller, use a 34 degree angle, and from here to here for depth and width. And that's how those work. They're plastic, but they still work very good for V-belts. You don't have to be perfect, 100% perfect on V-belt grooves. This is basically angle gauges for checking angles. That's a 15 degree angle, 15 degree angle here or here, depending on how you want to put it on your part. And again, I bought that set years ago, and I've never used it. It's just something, like I said, I like to collect tools, and if I see something, especially if it's on sale, I'll buy it. This here works the same way, except it works on radiuses. And I've had this set, gosh, for probably close to 40 years. Matter of fact, I don't know if you can see the brand on it, it's Ash brand. There used to be a tool company called Ash. It was kind of like Enco or MSC. I don't think they're around anymore. They've been gone for years. But I actually bought that from the Ash Tool Company. That's how old this thing is. If anybody knows how old they are, please leave a comment. Let me know when they might have went out of business. But this is something I use a lot. Cutting radiuses on shafts, checking radiuses on things. Radiuses on shafts, when you're machining a shaft, radiuses are very important. It's the difference between a shaft breaking and holding up. So it's critical to get the right size radius on a shaft and make sure you're fitting it to the right size radius. So that's just another type of measuring tool. And they make them different ways. Here's like a blade type. These are smaller ones. I have another one there that's bigger, but that's pretty much that. These are called adjustable parallels, and as they slide in and out, you know, of course they get thicker or thinner as you slide them back and forth. And these things, I've never used them as a parallel. I've always used them as a measuring tool. And it gives you the range of each one. They go all the way from, you know, a small size here to the biggest size here. And what you do is, if you're needing to measure down in a groove or a step down where you can't get a mic into it, you can slide it down in there and adjust it out until it just fits that groove. And when you pull it out and you mic that, that'll tell you what the width of that groove is. So they work great for that. There's times when you can't get anything else down into a groove, and that works good. So that's how those were used. And again, I'm rushing through this stuff because I want to try to get it in a short video. I want to do future videos showing an actual use of these, so it makes it a little bit easier to understand. But they're pretty well self-explanatory. Here's another style of angle block. You can see that one there is 20 degree angle, and it's you can use it two different ways. If you're wanting to check an angle, or you can put it in a mill, you know, and use it as a parallel in the vise and set your part on it, and you know it's set at 20 degrees if that's what you need. And they go all the way from 1 degree up to 30 degrees. And the nice thing about that, you can stack them to get a different angle, you know, combine the angles and stuff. So that's what those are used for. I've got a little something different here. I found this in my box, and I've actually used this a couple of times, and I'm not sure how old it is. They make newer ones a lot nicer than this. I've had this thing forever. It's an RPM gauge, and it's so old that you have to count the revolutions. So what you do is you'd have a shaft spinning, you put this against the end of the center on a shaft, and as it spins, you can see that dial moving, and you see the dot here and the dot here. You'd hold your finger like that, and it's spinning. You'd have to count those dots as it went around. One revolution is 100 RPMs. So you have to count if it went around 10 times, you know your shaft's doing, in a minute, it's doing 1,000 RPMs. You'd not only count it, but you'd have to watch the time. I have another one somewhere and I can't find it right now, but it's actually got a dial on it that will show the actual RPMs on it. But this one's so old, that's the way it worked. I thought it had a date on it somewhere, but I don't see it on there. I could have swore it had a date. I have another tool here I want to show you in a minute that does have a date on it. That's a Starrett brand. I have this here. We did a lot of tool and die work, and we had the Rockwell, standard Rockwell hardness testers and things like that. But this I picked up somewhere, and I actually had to use it a couple times because the part was too big to fit in our hardness tester. But the way this works is you pull this plunger up and it locks in place, and then if you put it down on a piece of hardened steel, and it works better on a bigger piece because of the density of the steel, but basically you'd put it down on there and push the lever and it would bounce, and then it would bounce, that plunger would bounce back up, and you'd read the scale here, and then they've got a scale here that you read in the box that whatever this reads would be down here, and you'd transfer over to, like if you were doing Rockwell C or Rockwell B, it would tell you what the actual hardness of this part is. This is so thin and sitting on this carpeted surface, it's not getting the bounce back that it should to really give you an accurate reading, but on big shafts it works great, and it's actually pretty accurate. But it's something I've never ran across before, and this is the only one I've ever seen, so I just wanted to kind of show you guys that. Moving on into measuring angles again, this is called a Miracle Point Mercury level, and the reason it's called a Mercury level is it's balanced with a mercury inside here on the needle, and this is magnetic. The base is magnetic, so you can actually set it down on a shaft. And say if you were putting keyways at 90 degrees on a shaft, you set it on 0. When you cut your first keyway, you'd loosen the key, the shaft in the vise, and turn it around until it read at 90 degrees, and you clamp it down, and that gets you your 90 degrees. And you could also, like if you wanted to mark a bolt hole or something on the top of the shaft, you set it on 0 and come down and drop that down against it, and it would mark the point on the shaft where that hole would be centered on top of the shaft. It's a very accurate way to measure angles and to set angles. This is another style mic. Again, I got this when I was probably 12, 13 years old. My uncle worked in a shop. He was an inspector, and when he left that job, he had this mic, and he gave it to me because he knew I was into machine work. And so this was probably my second tool I had as a kid, growing up and starting my machine shop career, and I've kept this. It means a lot to me that my uncle gave it to me, but I've used it a lot. And I've got bigger depth mics too. This is for measuring down into holes or slots into parts. And again, it works just like an outside mic, except you read it backwards, if that makes sense. And then you can put different stems in it for different depths. This one only goes from 0 to 3 inch, I believe it is. I've got another one that goes, I think, to 12-inch depth. But this one means the most to me because it was given to me by my uncle, and since then he's passed away. This is another style tool to measure with. It's a Vernier Bevel Protractor, they call it. And again, you put different blades in it, you can turn it to different angles, and it's very accurate if you're laying out or checking angles. It's got a magnifying scale in there, or glass in there, so you can read the scale, and reads off in, it said Vernier, it's not really Vernier, it reads off in degrees and minutes. I don't think it goes down to seconds. Yeah, it looks like it does go down to seconds. So it'll read off into seconds in there, so it's a fairly accurate bevel protractor. This is a dial depth gauge. Again, it just uses a dial indicator. It's got different length tips you can screw on the end of it to go down. I think it goes down to 6 inches, 5 inches maybe. And again, it just goes down into grooves and stuff like that if you want to measure down in depth, and then you just set it to 0, and it's got different little gauges you can set there to set your, say, your limit. Say if you're doing plus or minus for tolerance on your depth of groove, you can just set those, you know right away if it's within tolerance or not. They also make, Starrett makes this, and I've had it for years too. It's a little base that actually slides onto a regular dial indicator, and you can use a dial indicator, which that's basically what that is, but you can use a dial indicator the same way. You know, you rest this on a surface and your plunger goes down into a recess or a hole, measures the depth. It just, I think these were out before this came out actually. And then I get into, again, dial indicators. As a machinist, you're going to use a lot of different kinds of dial indicators. This is the most common I use for dialing a part in a lathe or a mill. You can tram your table in with this. I mean, you can use it for a lot of things. Same with this. This can sit on the ways of the lathe or the mill, and you know, you can set your 0 so you know when to come to stop. If you don't have a digital readout on your lathe or mill, they work really good. And this is a magnetic base you can turn off and on. It's like a permanent magnetic base. It's not electric or anything. It doesn't have batteries in it. And I found out when I was young, I dropped it and this handle popped out and the magnet came out. And when I put it back together, it didn't work anymore. When that comes apart, it loses its magnetism. It won't work anymore. It'll still, you can put it back together and make it work, but it won't have a magnetic pull to it anymore. Where this is a permanent magnet and there's no off or on it. And the bad thing with this thing, if chips and stuff get stuck to it, you got to either take an air hose and blow it off or take a rag and wipe them off or anything. Where that magnet, you can turn it off and then clean it off. This is another style dial indicator. It's called a last word indicator. It's really handy for dialing in a lathe or in a mill, I mean. And there's different attachments that you can put in it. The nice thing about it, it's small and get into tight places, and you can make it work. This particular one, it's a Starrett. If I push up on the bottom of the needle, it makes the needle move, and if I flip this little lever, now you push down from the top, so you can make it work from either direction depending on how you have it in the machine or how you're wanting to read it. But that's a very handy indicator to have. If you don't have one and you're doing machine work, I recommend you get one because you're going to use the heck out of it. Here's a couple of different styles of that type of indicator. This is just a different brand. I think these are Chinese, yeah, made in China. The nice thing about these, you don't need to flip a lever. If you push down on the top, you can see the needle moves. Push up from the bottom, it moves. So it reads from either direction without having to flip a lever. This one here, I have a clamp on it that clamps around the spindle of the mill, and then you can spin it around and dial in holes or dial along edges, however you want to use it. It's a real handy way to do it. And then this one's kind of the same way, except you'd put that like in a chuck or collet, and then you can spin the spindle and dial a part in. And again, those are the type of indicators, if you're doing a lot of mill work, you're going to use those a lot. They're very handy to have. This is another type of indicator to use in a mill, and I haven't used this thing in years, and I just got out of the box. I'm embarrassed. It was all corroded and it's still kind of gummy. I'm going to take it apart and clean it. But basically this thing's designed, you clamp this in a collet, and then you've got a rod you put in here so this part can't spin. And then when you spin this with a tip in it, I've got different length tips you can put in the end of this thing and dial a part in. You'll find on like a last word or something, as you spin it, the dial goes around, so you have to chase it around the mill. And a lot of times I use a little mirror just to see what it says so you're not having to move around the mill. Where this particular indicator, the indicator will stay stationary, as you spin this, and you can read the dial right there as you spin it around, so you don't have to chase this around. It's a really nice setup, and I've used it quite a bit, but I haven't used it in the last few years. And I got it out, it was corroded, so I got to clean it up. But that's how that works. And again, that's a nice handy, if you're doing a lot of hole work and things like that, that's a nice handy indicator to have. And then I've got these. I've had these, God, since I was 17 years old, I think. And these are actually old type of, like that last word indicator. This one's, I mean, it doesn't even work. I don't think it ever did work, but I kept it because I thought it was cool. But basically, you move the needle back and forth, the tip back and forth, and this needle moves back and forth, and it reads out in thousandths of an inch. This one here, it still works to a degree. It kind of hangs up, but you can see the needle move, and it moves no matter which direction I push it until it sticks. And it's got a date on it, a patent date of August 24th, 1937. So that thing's old, but I never did use it. I ended up with it with a bunch of tools I bought from somebody sometime, and I just thought it was cool, so I always kept it. And like I said, I like tools, whether they work or not, or how old they are. It's just cool. This here is another attachment for the dial indicators. You can screw tips, different tips on them, off and on. That tip, this particular tip, and then that tip right there, I probably use more than all the rest of these combined in the 40 years I've been doing this or longer. These other tips are really cool, but I never really had a need for them. I think I maybe used this tip a few times, a flat tip, if you're trying to reach across, you know, a gap or a little, like between two teeth or something. But for the most part, that one did everything I needed, along with these two. And you definitely, again, if you're doing a lot of machine work, you're going to want some tips, because there's going to be times you just need that extra little bit of reach or span across a gap or something when you're doing indicating, especially if you're trying to indicate something in a lathe and then it's spinning and it's hit or miss. On a thin tip like that, you hit it just wrong and it tips your indicator down, where if you got the bigger tip, it'll ride across things like gear teeth or even threads. I mean, I've taken where I'll take a 12-inch scale, lay it down on the ways, have it resting against the indicator like that, and have your part here because it's got teeth or whatever in it, or a gap between, you know, widespread of maybe threads, and it'll let your indicator run against that, and you can indicate something, and it works really well. Again, a lot of this stuff I'm talking about now, I want to show in more depth as we go along, because a lot of the stuff I've learned over the last, well, really almost 50 years now, I hate to admit it, but I think it would come in handy for a lot of people that are doing a lot of machine work or learning machine work. There's so many shortcuts and little tips on how to repair something or how to thread something, how to dial something in. Things like using a steady rest and stuff like that. But again, I want to get into that in more depth in different videos. So here's another type of indicator. This is a button back indicator, obviously because the tip's on the back of the indicator, so it's called a button back. It works the same way as the last word indicator or the other indicators. It's just a different style where maybe it'll reach in better or work better in a certain circumstance than what the other ones would. And again, I've used this indicator a lot. It's a very handy indicator to have. Here's a couple more things here. This is a height gauge. I think this one's a 10-inch. Yeah, this is a 10-inch height gauge. It's a Vernier Scale height gauge. Again, it works very nice. You can use it, I usually have these set on my surface. I have a granite surface plate, I have these set on there. And you use it for measuring a part, or you can actually use it for laying out a part. It has a carbide tip on it there, so whatever you set it to the height and you come across a part, you can scribe your line on it like you're wanting to do layout lines on a block. Set it on your surface plate, you put layout fluid on it, come in and set this your height and mark it. It's accurate as all get out. Very good for doing that kind of stuff. This here is a dial height gauge. It works the same way as a vernier, except again, it's like a dial caliper. It has a dial on it, reads out here in hundredths, and then over here in thousandths. So as you go up and down, you can set it exactly where you want it, or if you're measuring a part, you can get the exact height of the part. And again, it's got the carbide tip on it, so you can use it as a layout tool. And again, I've used this a lot, used it in conjunction with my granite surface plate. It works really good. Just got a couple more things here and we'll be done. Again, back to gauge blocks, or more commonly known as Joe blocks. For originally the manufacturer of these blocks was Joe Hansen, and so that's where they got the nickname Joe blocks. But basically they're just gauge blocks. You can call them rub blocks, whatever, because you can actually call it ringing these in. If you, and again, these need to be cleaned and oiled, but when they're prepped properly, you basically just rub them back and forth together like that, and they'll lock together. You can't hardly get them back apart again. And it makes it really good if you're having to stack blocks to get a certain measurement that you're wanting to check. Again, this works good if you're going in between gaps in a part. You can stack these up because they're different thicknesses and get a perfect exact measurement. Or if you're needing to set something up in a mill, like using a sign block, you figure out what your sign angle is, and it'll tell you how thick of a block you need to set that angle to just the perfect angle, and you stack these up to that, put it under the sign block, and put it in the vise, and you'll have a perfect angle. And again, I want to show that in future videos because it's I think it's kind of important to know how to do that kind of stuff. And this is just a different style of gauge block. These are round instead of rectangular like those are. I think these are a lot more common than what these are. But again, there are certain times where these work out really good. And you can stack these together and put set screws between them and lock them together that way. They don't ring together like these rectangular blocks will for some reason. I guess they do to a degree, but not near as good as the way these things hold. I mean, you ring them together and you can't really get them back apart. But that's just about it. I think I have one more thing I want to show you. It's kind of one of those things that I bought because I thought it was cool. I've never used it, and I don't know if I'll ever use it, but it was on eBay one day, and it went really cheap, and it's a Machinist micrometer, or microscope. And you have different lenses that you can put in the bottom of this that's got degrees laid out on them, or this particular one has thousandths of an inch laid out in it, so you can actually set it down on a part, and say you're wanting to measure something, but it's too small to measure with a mic, kind of like using an optical comparator. This works basically the same way on a much smaller scale. This screws onto here, and this flashlight goes onto there so you can light it up, and then you just adjust it till you can read it, and then there's lines in there, which I don't think I can show it on the camera, but divided by 1/1000th of an inch. So if you got it like a little hole in something you're trying to measure and you can't get anything in it, you can put this on it and then adjust it so you can see which lines line up with it and count the number of lines, and it'll tell you how big that hole is. Again, I bought it because I like tools and I just thought it was kind of cool. I don't know if I'll ever use it but I'm going to try to find some project that I can use it on just to show you guys how it works. But that's pretty much it. Okay, well that pretty much covers everything I wanted to cover on this video as far as measuring tools, and I hope you enjoyed it. If you have any questions, then please leave a comment down below. I'll be glad to try to answer anything I can or find an answer for you if I don't know it. In the future videos, I want to try to cover more uses, actual use of all these different tools, so you kind of understand a little bit better about how they work and some of those shortcuts you can use using them and stuff like that. There's a lot of little things I learned over the years that you won't find in a book. I was very fortunate working in a job shop. Probably, as far as I'm concerned, probably the greatest job shop in the whole country. It was family owned, started by a gentleman, and his son is running it now since he passed away. But it's amazing the quality and type of work that we did at that place, and the different things I learned as far as how to do machine work. But I'm really hoping to be able to share that knowledge with everybody, and somebody can get something out of it, or at least maybe enjoy, some of the crazy things and ways that back when I was young, how we had to do stuff because of the equipment we had and the materials available to us that we had to use. But thanks for watching the video today. If you like it, please hit subscribe and like button and share it with your friends. Have a great day.